Okay, so we are going to look at reviewing the exponent laws. First of all, let's look at an exponent. If we have a variable and or a number that has an exponent, let's first of all look at some of these terms. The base is the number at the bottom. Could be a variable, could be a number. The exponent is the value raised, and the power is the whole thing together. So we just got to make sure we remember all those terms: base, exponent, and power. So let's look at these exponent laws. First exponent law is the product law. So the product law tells us if we have two bases that are the same, in this case it's x and x, we add the exponents. So if we are multiplying two things together, the base is the same, we add the exponents. When we're dividing and the base is the same, we subtract the exponents. The power law, if there's an exponent on the outside, like in this case, and we are trying to multiply it into everything inside the brackets, then the exponent applies to every base. And this should actually be a y. So xy to the n is xn, yn. And we're going to do some examples about this in a second. If we have a fraction inside the brackets, same thing applies. The exponent on the outside becomes the exponent of everything on the inside. And the last exponent law is the power law. If we have an exponent on the inside and an exponent on the outside, what we do is we multiply those exponents. So we add the exponents if it's inside the brackets. If there's an exponent inside and an exponent outside, we multiply them. That's a quick review of the exponent laws. Let's look at some examples. So we're going to simplify these exponents. The first thing we have is we have 3 and 3. The base is the same. This is the product law. So if the base is the same, what we do is we keep the base and we add the exponents. So 3 to the 3 plus 4, which becomes 3 to the 7. And that's an example of the product law. In the next example, in B, we have the base the same. The base is both 4, and we're doing division. This is where we subtract the exponents. So it becomes 4 to the 3 minus 2, which is just 4 to the exponent 1. And anytime we have an exponent 1, we don't write it, we just write it as the base. So if we have a base and there's no exponent, the implied exponent is exponent 1. That is the quotient law. Now let's look at the power law. If we have an exponent on the inside and an exponent on the outside, what we do, according to the power law, is we multiply these exponents together. So 2 to the 4 times 3. Now we're not timesing the base, we're just timesing the exponent, so that becomes 2 to the 12. So that's a quick review of the exponent laws. Let's look at it with some variables. Because it doesn't matter whether the base is a number or a variable, the laws stay the same. In this first example A, the base is the same. The base is both x, and we are trying to multiply those together, so we add the exponents. X to the 3 plus 4, this becomes x to the 7. Same thing down here. If the base is the same, the base in both of these powers is b, we subtract the exponents. B to the 3 minus 2, which becomes b to the 1, which again, we only write as b because the implied exponent is a 1 if nothing is written. Well, let's look if we have r to the 5th all cubed. Again, this is an example of the power law. We multiply the exponents together. And we are going to get r 5 times 3 is r to the 15. So there are some examples using variables as well. Now let's look at zero exponents. So what happens if we have a zero exponent? Well, we're going to have 5 to the 3 over 5 to the 3. And I want to just explain and make sure you're clear where this comes from. Now remember, if we have 5 to the 3, that's the same as 5 times 5 times 5 on the top. And 5 to the 3 on the bottom is the same as 5 times 5 times 5. Now if we do the multiplication, 5 times 5 times 5 is 125 over 125. And if you remember from fractions, if the top numerator, bottom denominator are the same, we could divide both by 125, I should say, and we would get 1 over 1, which is just 1. So 5 to the 3 divided by 5 to the 3 is just equal to 1. That's if we were just doing straight multiplication. Let's look if we have the exponent laws and we're using the exponent laws. Well, the exponent laws tells us if the base is the same, we subtract the exponents. So we would have 5 to the 3 minus 3, which is 5 to the 0. And we know 5 to the 0, the answer has to be the same in both. That's going to equal 1. So 5 to the 0 is equal to 1. This is where we get our rule for exponents with a 0 or 0 exponents. Any base with an exponent 0 is always going to equal 1. It does not matter what the base is. It could be a number. 4 to the 0 is 1. So a bigger number, 40 to the 0 is 1. Or a variable, a to the 0 is 1. Anything with an exponent 0 is 1. What about negative exponents? We're going to explore negative exponents in the exact same way. 4 to the 3 is the same as 4 times 4 times 4. On the bottom we get 4 to the 4, which is 4 times 4 times 4 times 4. Now, if we were simplifying this, if we have something in the top and something in the bottom the same, we can divide both by that value. So 4 and 4 is common. 4 and 4 is a common. 4 and 4 is a common. So what we have left here is we have a 1 on the top and a 4 on the bottom. So 4 over 3, 4 to the 3, divided by 4 to the 4 is 1/4. Now we're going to use this with exponent laws. 4 to the 3 minus 4 is the same as 4 to the negative 1. But remember, we got this answer to be a 4/4 and 4 to the negative 1. So when we put those together, we would get that 4 to the negative 1 is equal to 1/4. This is how we get negative exponents. If we have a negative exponent, what we do is we take the reciprocal, or we flip it. So 4 to the negative 1 is the same as 1 over 4, because we flip this value over. This leads to the rule for negative exponents. If we have a to the negative m, to get rid of the negative exponents, we just flip it. So this is not over anything yet, so we're going to put it over 1. If we flip it, it becomes a to the m. Just flip it over, take the reciprocal, and the negative disappears. Now if there's a negative in the bottom originally, and we want to get rid of it, we flip it again. We take the reciprocal. This comes to the top, this comes to the bottom, so we would get a to the m over 1, or just a to the m. So there is a review of the exponent laws. You can go do the practice worksheets to get a little more additional practice on all the laws for exponents which you'll use throughout Math 10.